Welcome to this presentation from the Urban Penguin, a presentation where we're going to dive into how we can make secure tunnels using SSH. Let's take the scenario where you have an HTTP server that is perhaps an embedded device that cannot be upgraded to HTTPS. You need secure communication from your laptop through to this device. Well, the really nice thing about this is it's relatively easy to set up if you're using Linux. I have a couple of Rocky Linux systems here. One is acting, let's say, as my laptop, and the second is then acting as my embedded device that is only working with HTTP. So if I try curling 172.16.247.158, I think should be the IP address, I get my secret site coming out. However, because it's such a secret site, I'm concerned that my communication is in clear text over the network. So, of course, I need to be able to protect it. But it's an embedded device. It doesn't work with HTTPS. So what options are open to me? Well, we can go through and run SSH. And I'm going to put in a few switches. So we're going to specify to run SSH in the background. And the uppercase N is say don't run any commands. I don't really want to SSH into the box. So we just need to set up the tunnel. We're going to be listening on port 8080. And that's going to be on our local host, so on my laptop. So I'm going to be connecting on my laptop. My laptop is going to make the tunnel through to port 80 on the remote system, and we access that through Vagrant and then if I use escape and dot, I can get the IP address back up. It's my last argument. Escape and dot brings up your last argument. Now I'm being prompted for the password. I could obviously use key-based authentication, but for a simple demonstration, I haven't set that up. So you can see now that I'm back on my Rocky system, but I've established an SSH connection to the remote system. If I look at SS-NTL, we can see then that we are in fact listening on port 8080, and we can then go through and use the curl command, localhost port 8080, and we get the website coming back. But the traffic's gone through to my local host. It's been sent through encrypted on port 22 to the remote web server, where it's been passed through to port 80. Now this should time out automatically based on the client alive timeouts. However, if we want to get rid of it once we are finished, we can go through, and if I use pgrep to search for processes for the user Vagrant that have got SSH in their name, and we can see, well, we get a couple coming back. But if I look for a little bit more detail, I can go through and specify a longer listing. So I'm just putting the L in front of the U, and we can see, well, one is the SSHD connection. So this is more managing my client connection as I've connected into the Rocky One system. But my client connection out is then what we're seeing in 6170. We can always check that with more details. If I look at PS minus long for the process 6170, and we can see, well, it looking good. Let's do a full listing as well. We'll get more of our client command in this now. And we can see then that is then my command. So I can go through and do a kill 6170. When we go back now and take a look, that process has gone. And obviously when I clear my screen and then go through and take a look at my open ports, well, that now has been taken down. Rather than run from the command line, it might be easier to create your own SSH config for this. So I'm going to go through and look at editing my .ssh directory. I'm working in my home directory. In my home directory, I've got a .ssh subdirectory, and we can then go through and create the file config. If you haven't got the .ssh directory, you can create it, but you're going to have to set it to private permissions, so it should have a mode of 700. When I look at my config file, in here I can then go through and describe myself a host. I'm going to call this host, let's call it my tunnel. Inside of this, I can go through and specify the host name or IP address that I want to connect to. So I can go through and specify the host name, and I can specify the IP address of 172.16.247.158. Obviously, you use the IP address that works for you or the host name. We can specify the user, and I'm connecting as the Vagrant user on my systems. We can then go through and specify our local forward. And this is going to be the same things as we configured before. 8080 on the local host being forwarded to port 80 on the remote host. It's a little awkward, I think, the way that it's written, because it's 8080 on the local host. The colon is just separating our arguments. We can allow compression. So we can turn compression on. That's optional, we don't need it. And we can specify request TTY, and we can set this to no. We don't need a terminal opening. So once we've got the configuration in place, then I can go through and save this. We do just like the directory. If you needed to create the .ssh directory, it needs the permissions of 700. If you create the config file, then we must set the config file with the mode of 600, so it's private through to the user that created it. Otherwise, SSH won't work with it. I can then create the tunnel, so SSH running in the background, not requesting any commands, and running the my tunnel. Everything else is then specified within my config. And I say, ideally, you'd have key-based authentication, but now I can go through and curl to localhost on port 8080, and I get the secret site coming back in. And again, I can allow this to time out through the normal SSH mechanisms, or I can go through and kill the process. If you need to create the tunnel infrequently, then creating the definition at the command line might be the way to go. And you can see that we can use SSH minus lowercase f to specify the SSH command runs in the background, the uppercase N specifying not to run any SSH commands once connected, and the L for listening. We're listening on port 8080 on the local host and redirecting to port 80 on the remote host. We're connecting as the user account user to the server that we've called, in this instance, web. For something a little bit permanent, we can make sure that we create an SSH config for this. You have to ensure that you have a .ssh directory in your home directory, and it needs to be set with private permissions. Using mkdir -p, it doesn't matter whether the directory is there or not, it won't error if the directory is already there. We can then create a config file within that subdirectory, defining a host called mytunnel, setting the correct host name, the correct username, setting our port forwarding, allowing compression if we need it, and specifying that we don't need a terminal. The config file also needs to be private. It doesn't need the execute permission because that's needed to enter the directory, but not a file. So the file should be set with the permissions of 600. The ease of connecting now is shown when we can just specify SSH-FN mytunnel, and we are good to go.
All that is left to say is thank you for watching. If you've enjoyed this, then you are probably sadder than I first thought. For more of this drivel, please subscribe, like and comment to @TheUrbanPenguin.